The next element here in our ground rules is nitrogen, and nitrogen likes 5. So nitrogen is happy at 5. So how will we do this for nitrogen? So nitrogen is going to have 1 electron, 2 electrons, 3 electrons, 4 electrons, and 5 electrons. So as an example, instead of putting these electrons as dots, they're ready to bond. Notice here we have what's called a lone pair of electrons that reside on the nitrogen atom. So this 1 electron is ready to form a bond, okay, with anything. I'll just call it R. So R could be any atom or a collection of atoms. This nitrogen here on the right-hand side is ready to form a bond. I'll call it R1, though it really doesn't matter. This electron at the bottom is ready to form a bond. And then we have the 2 lone pairs of electrons sitting on top of the nitrogen. So this would be the best representation of nitrogen as the central atom. It's very important you recognize that nitrogen here is the central atom. Okay, so ammonia is NH3. So we can just substitute the substituents with hydrogens, and we'll get the correct, most prominent Lewis structure for ammonia. So don't forget that lone pair of electrons really are going to distort the geometry, because remember, Lewis structures also will have a 3D representation that we will go in a later video. So let's do our most important rule here, and that's formal charge. So formal charge is happy minus number of electrons around it. So 1, 2, 3, 4, 5. We count this individually because it's a lone pair. So once again, 1, 2, 3, 4, 5. Nitrogen is happy at 5. 5 minus 5 is 0. Okay, so nitrogen in this molecule, ammonia, has a formal charge of 0, which is good. Okay, you notice there is no charge in NH3, so obviously there's going to be no charge when we do the formal charge considerations. The next rule here is the octet rule. We make sure we have 8 around the nitrogen. So 1, 2, now we count everything, even the ones that are part of the single bond. They belong to nitrogen just as much as they belong to hydrogen. But looking at the octet rule for nitrogen, it's going to be 1, 2, 3, 4, 5, 6, 7, and 8. So the octet rule for ammonia is also satisfied. Let's look at cyanic acid, which is HCN. So here's an example of cyanic acid. So cyanic acid is an example where nitrogen is not the central atom. The central atom is carbon. But let's take a look at our formal charge and octet rule considerations for this one. So let's look at the octet rule. Okay, we're going to count everything. This is shared, but it just as much belongs to nitrogen as it does to carbon. So 1, 2, 3, 4, 5, 6, 7, 8. So the octet rule for nitrogen, again, this is exclusively on nitrogen, is good. The most important rule is formal charge. So the formal charge of nitrogen is going to be 1. We're going to count this as 1 for formal charge considerations now. 1, 2, 3, 4, 5. Okay, so we count the bonds as 1. 1, 2, 3. The lone pair gets counted individually. 4, 5. Nitrogen is happy at 5. 5 minus 5 that's around this nitrogen is going to be 0. So the formal charge of that nitrogen in cyanic acid is going to be 0.